Hi everyone, welcome to NumPy Part 2 video. This video has 4 sections. In the first section, we will see how to create NumPy array in 2 different methods. Then after that, we will see the difference between the Python and NumPy data structures. We will see the vector arrays and matrix arrays, and we will also see how to check the shape of the NumPy array. Then in the second section, we will see how to add, remove or sort elements within NumPy array. And in section 3, we will see the arithmetic operations such as addition, subtract, multiply, and divide. And in the section 4, we will look at the useful NumPy functions such as arange, linspace, zeros, and ones. This is the exercise file that I'll be using for this video. You can go to GitHub repository and download this from here. You can find the link in the description. To get the most from this video, keep practicing as we go along. So let's go ahead and see how to create NumPy arrays. Currently, we cannot use NumPy functions in this file. In order to use the NumPy function in this file, we need to import it. To import it, you can write import and NumPy. And it is preferable to give it a short name as NP. And now if I execute this line code, all the NumPy functions will be accessible using NP. And next is checking the version of NumPy. It's important to check the NumPy version because currently it's November 2020. So maybe by the time you're watching this video, there is a new release of NumPy and you have more functions available there. To see the version of NumPy, within the print function, type np dot underscore underscore version and underscore underscore. And now you can hit shift and enter to see the version. The version that I have is 1.18.1. So if you have the latest version than my version, then it's fine, no problem with that. But if you have the old version, then it's better if you can upgrade to this version or the latest version. To create a NumPy array from the list, we can create a list first. I'm giving it a name mylist, and I'm going to give it some random values. Now shift and enter to execute the cell. And now I can write np.array and I can pass the list here. And if I hit shift and enter, I can see the array has been created. I can also save the results in a variable, my array, and I can access that variable in the next line. And now you can see I'm accessing the array from a variable and the result is exactly same. I can also create NumPy array from a tuple. I can create a tuple first, my tuple. Within the brackets, I can give it some random values, 10, 20.5 and 30.7. I can hit shift and enter to execute this cell. The cell is executed. Now I can create a new variable called myArray1 and I can type np.array and within that I can pass my tuple. And I can access myArray1 variable in the next line to see the outcome of array. Now if I hit shift and enter, I can see the array has been created. But there is one thing to note in the outcome, that I passed 10 as an integer here, but it is promoted to a decimal number because NumPy can only have one data type and that's why it has converted all the numbers to decimal numbers. Now to see the difference between the Python and NumPy data structure, I'm taking my tuple as an example and I'm multiplying it by 6. So it has added the same 3 elements 5 more times. So means to say there are 6 copies of same 3 elements in the tuple. I want to see the effect of the multiplication on the NumPy array. Now I can hit shift and enter to execute. And now you can see instead of creating 5 more copies, it has multiplied each element with the 6. So before it was 10 and now it's 60. 20.5 is converted into 123. So when we multiplied tuple with 6, it has created more copies of that. But when we multiplied NumPy array with 6, it has multiplied each element of NumPy array with 6. So we have discussed in the previous video before that if you are creating NumPy array from one-dimensional array, then that will be a vector. Or if you are creating NumPy array from 2D or 3D array, then that will be a matrix here. So this is two-dimensional array and that's why this is called matrix. So first I need to execute both cells and now we want to check the shape. So shape property of NumPy array is to check how many dimensions and elements are there in a NumPy array. So let's say if I want to check the shape of a vector variable, I can type vector.shape and I can use shift and enter to execute this cell. So this is showing me that this vector has 4 elements, and we can see it has 4 elements here. Now I want to check the shape of matrix, matrix.shape. If I execute this one, this is showing me that this matrix has 2 dimensions and 4 elements. So first section has been completed. Now we'll focus on the second section, which is add, remove or sort elements in NumPy array. So I created a NumPy array called vector before. If I execute, I can see this has 4 elements. And now if I want to add one more element to this NumPy array, I can use the function np.append. As the first parameter, I can pass the NumPy array, and then as the second parameter, I can pass a new array that I want to append. So let's say I want to add one more number, which is 5. I can just type 5 and hit shift enter. So the new array has been created from the elements 1 to 5, and it has the new appended element as well. But the result is not saved in the vector variable. So what I can do, I can copy the variable and assign the value to the vector array. So whatever the change we are doing here, it will be assigned to a vector variable. So vector variables has 5 elements, 1 to 5. To remove an element from NumPy array, I need to call a function np.delete. And in the first parameter, I can pass the array. And in the second parameter, I need to pass an index. So let's say if I want to delete 3 from this array, so the index for the 3 is 0, 1 and 2. The index is 2, so I can pass 2 in the second parameter. If I execute this one, now you can see the number 3 is deleted from this NumPy array. New array is not assigned to a vector variable, so I can just assign it. I can say vector is equal to the code on the right side. So the new array will be assigned to a vector variable. To sort the elements in NumPy array, I can use the function np.sort, and I can give it array as a parameter. So all the elements within this NumPy array will be sorted. If I execute this, numbers are sorted. So if I want to sort these elements as descending, I can use brackets, colon 2 times and -1. And now you can see the numbers are sorted in descending order. We can also perform arithmetic operations to the NumPy array. If I want to add 100 to each element in the NumPy array, I can add that. So you can see 1 is converted into 101, 102, 103, 104 and 105. Thus in the same way, I want to deduct 100 from each element. So now you can see the results of the subtraction. I can also multiply each element with a specific number. I can multiply it and you can see the result. This is very useful if you have the cost in the US dollars and you want to convert it into a different currency. You can just multiply it one time and all the costs, like 1000 rows, will be converted into different currency. And the same way you can divide it. So if you have a currency in US dollar and you want to convert it into a different currency, you can just divide it by that number and you will get the currency. And now the last section, which is arange, linspace, zeros and ones. So we will start with arange. If I go to the NumPy website to see the definition of arange, it says return evenly spaced values within a given interval. And it has 4 parameters: start, stop, step and dtype. And now we will see how to use these parameters to create arange array in a different phase. To create a NumPy arange array, I can type np.arange and I'm passing one parameter, which is 10. So if I pass one parameter, arange function will consider this as stop and it will consider the start value as 0 by default. Now if I execute this cell, it will create an array which is starting from 0 and up and until but excluding 10. And now I'm copying the same code in the second cell and giving it a second parameter as 25. So if I execute this, you can see it has created an array which is starting from 10 until 24. So it's not including 25. Now if I copy this code and pass a third parameter as 5, so that third parameter will be considered as step because 10 is start, 25 is end, and third parameter will be the step. So step mean between every two elements there will be a spacing of 5. So if I execute this code, now you can see it has created 3 elements, which is 10, 15 and 20. Because it will not consider 25, it will be below 25. So with the spacing of 5 number, there were only 3 numbers between 10 and 25. So if I copy the same code and change 25 with 26 and execute this, now 25 is the part of the array because this is excluding 26. So all the elements with the spacing of 5 will be considered, and that's why 25 is there. So in the Python, I can use position based parameter, or I can also use name based parameter. So if I execute this code is also working as well. And now if I want to create an array from 1 to 100, I can type np.arange, starting parameter as 1 and ending parameter as 101, because it will not include 101 there, it will be below 101. And we can pass 1 as a step. And if I execute this, you can see printing an array from 1 to 100. And now if I want to print a list of all the odd numbers, I can change the step to 2, and if I execute this, you can see all the numbers are odd numbers. And now the Linspace function, if we go to the definition in NumPy website, it says return evenly or linearly spaced numbers over a specified interval. And it has 6 parameters. Start and stop are mandatory parameters, and then there are 4 optional parameters. So the first example that we will start with, we'll pass it 3 parameters. And for that, I'll write np.linspace. And the first parameter I'll pass 1, second 10, and third parameter I'll pass 10. And if I execute this code now, the numbers are starting from 1 as stated here and ending at 10. So stop number was 10 here. And we specify the total numbers should be 10, and that's why the spacing between each element is 1 and total elements are 10. If we change this 10 to 20, and start and end will remain same as 1 and 10, but it will create 20 numbers. And now you can see there are total 20 elements where the spacing is reduced from the 1 to around 0.5. So one difference between arange and linspace is, in arange, top element was excluded. In linspace, top element is also included as array element. In linspace, you can also specify the return step. So as a fourth parameter, return step is equal to true. And if I execute this, the second parameter is the return step. So this is the spacing between every 2 elements of the array. So if I save the results in a variable, my linspace, and execute this, first element of this variable will be an actual array, and the second element will be spacing between all the elements. And if I copy the same code again and set the endpoint value to false, you can see the stop point is not included now. It's not the part of array. And now the zeros. Zeros will return a new array of a given shape and type filled with zeros. So to create a NumPy 0 array, type np.zeros and pass a shape, let's say 5. And if I execute this code, it's creating the array of 5 elements and all the elements are 0. If you want to create a multi-dimensional array, you can pass a tuple of a shape. So let's say if I want to create 5 by 5, I can type 5, 5, and it will create a shape of 5 rows and 5 dimensions. And now the ones. If I type the function np.ones and pass it a parameter as 7, and if I execute this, it will create an array of 7 elements and all the elements will be ones. We can also create 2D array of ones by passing a tuple. So instead of one value, we can pass a tuple, let's say 5 by 5, and 2D array is created. We can also create 3D arrays. So I can pass a third parameter in a tuple. So now you can see it has created 3D array. So it's showing we have 5 dimensions, 5 rows in each dimension, and we have 3 columns. So one thing to note here, the value of all the elements is a floating point. So if I create a new array, np.ones, and with 5 elements, and if I set the d type is equal to int64, sorry, my mistake, I missed s here. So all the elements are integer now, and if I copy the same array again in the next cell and remove d type, all the elements will be a floating point again. So in this video, we have seen different ways to create NumPy array. We have performed different arithmetic operations, and we looked at linspace, arange, zeros, and ones. Thank you so much for watching this video.